In this movie, we will see how to uh, conduct a hypothesis test. There are certain steps that we will undertake in developing and conducting a test around a hypothesis dealing with the population parameters. The first step is how to formulate the null and the alternative hypotheses. And here we saw earlier that there could be two approaches. We could either formulate the null first, and this would be the case when we are trying to verify a claim we have about the population parameter. Then that claim becomes the null. The second context could be if we have a research study, we are trying to implement a change, and we are conjecturing that that change would improve the way the things were being done before. For example, in that case, we will formulate our alternative first, and we will let alternative be the finding that we hope to conclude once we have done our test. And then the opposite becomes the null. Then the second step involves determining the level of significance, or alpha. And as we've seen before, this is the probability of type 1 error. Our alpha can be 0.1 or 10%. In this case, our confidence level is 90%. Our alpha could be 0.05 or 5%. And then our confidence level in that case is 95%. Or our alpha, or level of significance, the probability of type 1 error, could be 1% or 0.01. So essentially we will work with 0.1, 0.05, or 0.01. So 10%, 5%, or 1% level of significance. Then once we have done these two steps, the next step involves collecting data and then constructing a formula that we call the test statistic. And then we will look at this test statistic, compare it to the probability distribution that we might expect our point estimate of the population parameter to have. So if we are doing a test around the population mean, then we would compare our test statistic with the probability distribution that the sample mean might have. And we have seen before that the sample mean could follow normal distribution, or it could follow a t-distribution. If we are doing a test around the population proportion, then we will look at the conditions within which we could have the population proportion, sample proportion, follow the z-distribution. Then the fourth step involves the decision process. So we have the level of significance. We will see what evidence do we have to support our hypotheses. There are two approaches we can do in the level of significance or decision process. One is the p-value approach. In the p-value approach, we look at the p-value that comes from our test, and we compare it to our level of significance that we determine. If the p-value that we get, and we'll discuss what the p-value is less than our level of significance, then we reject the null. If our p-value that we get is above our specified alpha, then we do not reject the null. The other approach can be the critical value approach. In the critical value approach, we will look up the critical value of the rejection region based on our level of significance, or alpha. And then we will compare that critical value to our test statistic. If our test statistic is more extreme, if we are doing a left tail test, if our test statistic is to the left of the critical value, then we can reject the null. On the other hand, if you're doing a right tail test, if our test statistic that we get is to the right of the critical value, then we can reject the null. And then once we have conducted a test, we can then interpret the statistical conclusion in the context of the problem. So again, the way we formulate test, it starts with defining the problem, defining what the context of the problem is. Are we trying to verify a claim, or are we doing a research study? And then we follow these sequential steps. And then the final step involves what should our conclusion be, again, in the context of where we began, the context of the problem. We talked about the p-value. What is the p-value? P-value is a probability that is computed using a test statistic. And the p-value essentially provides the evidence to support the null hypothesis. So if our p-value is really small, then we can say safely that there's a very, very small probability that our sample is coming from the population that supports the null. So a very small p-value is, in a way, an evidence against the null. On the other hand, if our p-value is large, and then this large and small is usually compared to our significance level. So if our p-value is above our significance level, we say that there is probably sufficient evidence that our sample may have come from a population where the underlying null condition could be true. So smaller the p-value, the harder it is to support the null. If the p-value is below our level of significance that we have determined, then we have pretty strong evidence that our sample is not coming from a population that supports the null, so we can reject the null hypothesis.